Hey, today we're going to talk about 8.8, Bioaccumulation and Biomagnification. So before we begin, check out the Enduring Understanding, look at the learning objectives, pause the video, review the essential knowledge, and set up your Cornell notes. So this topic of bioaccumulation and biomagnification is a bit of a review, but I'm just going to reiterate a couple of the key points that you should be aware of. So just a reminder that water is a polar molecule, which means that it has areas of positive and areas of negative charge. And this is because of the electronegativity of oxygen. It pulls the electrons towards it. So when something is water soluble, it will typically either be a polar molecule or an ionic compound. Ionic compounds are compounds that are made from substances with opposite charges, whether it is a molecule or an ion. And when something is water soluble, it is easily dispersed in watersheds. So an example would be something like acids. Nitrates are water soluble because nitrates are ionic compounds. They can also be easily absorbed by plants because they are traveling through the ecosystem and the watershed in the water. When something is fat soluble, it is typically a non-polar molecule, which means that it can be found in soils. It will also build up in benthic areas because it does not easily mix with or dissolve in the water. And it can bioaccumulate. And it bioaccumulates in the fatty tissues of an organism. So some famous examples, and we've talked about some of these, but examples of substances that can bioaccumulate or biomagnify: DDT. And DDT was an insecticide that was used in the 1950s. It was outlawed in the 70s, and it settled into the benthic segments, the bottom of a lake, river, or stream, and it accumulated in the organisms that lived down there, and then it moved up the food chain and accumulated in other organisms that consumed those benthic organisms. Mercury is released from a coal-fired power plant. In aquatic ecosystems, through the actions of bacteria, it is converted to methylmercury, and it also accumulated in benthic organisms. And PCB accumulated in whales in Puget Sound. Puget Sound is to the west of Seattle, and young whales would die at a much higher rate. So these are some examples. There are others, but these are any examples, especially the persistent organic pollutants, any of those fat-soluble substances, heavy metals that are going to be fat-soluble, are examples of substances that can bioaccumulate. So the reason that this happens, the difference between bioaccumulation and biomagnification. Bioaccumulation refers to the pollutants that are building up because of the amount of substances or food items that an organism would consume. So if you think that these primary producers have, two toxin dots each, the organisms at the next trophic level are going to have to consume multiple plants in order to survive. So they're going to accumulate more toxins. And the secondary consumer, or the third trophic level, in this case a bluegill, is going to consume multiple primary consumers and therefore accumulate even more toxins. As we move up, the toxins are increasing and almost increasing like in multiples. And the difference between bioaccumulation and biomagnification: accumulation basically means a big organism with a voracious appetite is going to accumulate or build up more toxins. So biomagnification refers to an organism's position in the food chain, in a trophic pyramid. Recall from earlier lessons that the 10% rule means that only 10% of the energy is available to the next trophic level. 90% of that energy is lost as heat. So one thing that has to happen is these organisms at higher trophic levels must consume multiple organisms at a lower trophic level in order to obtain enough calories and enough nutrients to survive. So as we move up, each organism is consuming multiple organisms from the lower trophic levels, and the pollutants are actually magnifying or building up. So it is assumed that a quaternary consumer is going to have more toxins than a tertiary consumer. And this is done with just looking at their position on a food chain, their position in a trophic pyramid. And quaternary will always have more toxins than a tertiary. This is what biomagnification is all about. So for your FRQ practice, I would like you to respond to this. Environmentalists are concerned that an additive in plastic manufacturing biomagnifies in the tissues of aquatic organisms in a nearby lake. Identify a testable hypothesis that the scientists may use for their study. So I hope that this was basically a review, informative. Thank you very much for your attention. I will see you soon.